This conference will now be recorded.
All right. So let's look at some of the networking tools that we use day in, day out. Just some of the standard, tools that we use. Either it be Windows or Linux operating system. Um, they kind of change. Okay, I mean the overall commands may be the same, but some commands they change because they depend upon how the utilities were written and who has written it. They may have different and syntax names that they've given to those utilities. So sometimes they change. Like for example, right, if you see it's IP config in a Windows environment. In a Linux environment, the equivalent command for this is ifconfig, right? Netstat is same, but so basically some commands may change, but overall pretty much the same. Okay, so we'll just look at some of these basic commands. In fact, we'll run these commands and see how the outputs are. We'll try to interpret what information we can get from these outputs. Okay. I'm going to use a Linux EC2 instance in order to run some of these commands. Okay. So just give me a minute, guys, while I'm trying to connect to my EC2 instance. Okay. Okay, guys. Hope you can see my EC2 Linux terminal now. Okay. So let's start with the first command, which is ifconfig. Okay. So when I run ifconfig, it is giving me these details, right? So the first one, what we see here, this one is the interface name. So to the left, the first one that you see here is the interface name. So the interface name that, like in this case, Amazon has given to this instance is ETH0. In fact, that's the standard interface name that Amazon gives for any Linux interface. It gives it as ETH0. If you add more interfaces to your Linux instance because you need more IPs, maybe one interface you want to use for production network, another interface ETH1 you want to use for backup network, right? So it basically gives ETH1, ETH2, and so on. Okay. And it is also telling me that this is the IP address. So this basically is the private IP address for this particular EC2 instance. Okay. And this is subnet mask, right? And this is the broadcast. It is also giving me the IPv6 address. This is the IPv4 and this is the IPv6. But like I said, our focus is going to be IPv4 with respect to this whole session. Okay, but although you have IPv6 IP address also assigned, this is the MAC address for this particular network interface card. Okay, and then you get some stats around how many received packets, what is the total number of bytes, and in terms of MB that we received, are there any errors, drop packets, frame errors? Similarly, on the transmission side. So you get all these stats for this particular interface in a single command. So one, I would use this command if I want to check the IP address. and which interface is that IP address sitting on. And if I want to know the MAC address, I can use this. Or if I want to see any errors are happening, right? This is basically an incremental counter. So let's say today it is 0, tomorrow it can be 10, right? And then day after it's 20. It doesn't mean that the 20 errors have occurred in that single day. It is over the period of time. It's an incremental counter. Okay. So, I mean, usually some errors can happen. For example, if there are one or two errors happening in a few minutes, right? That is okay. In few minutes, as in like 15, 20 minutes, if one or two errors happen, it's okay. I mean, think, over the network, you expect them to happen, okay? Depending upon, like the SFPs that you're using, the NIC cards that you're using, the cables that you're using, it is expected to happen sometimes. But if you are seeing a lot of errors, like maybe 10, 15 packet drops in like a minute, then there's something not right. You need to troubleshoot it. But obviously, this is not our infrastructure that, we get all this troubleshoot. If you're, I mean, this is basically AWS infrastructure, right? So if you are seeing any of that, then we have to report to AWS, or we have to um, recreate a NIC card. I will show you how to do that. And then this is
Mahi,
the loopback.
what is the
Go ahead.
version of that EC2 instance? 6.5 or 6.6 Linux?
This is an Amazon Linux. So it's a version 2 Amazon Linux.
Uh, my question is, when there is a maybe you know the difference between Red Hat 6 and Red Hat 7.
Right.
They have conventions of Ethernet interface naming. In the Red Hat 6, the
Uh-huh.
naming is Ethernet 0, 1, 2, 3.
Mm-hmm.
But the Red Hat 7, they have changed the naming from Ethernet 0 to ENC naming conventions.
Okay.
So networking has been changed from Red Hat 6 to Red Hat 7.
Okay.
So every time when we create EC2 instance, we will get the naming convention as Ethernet 0, right?
Yes. This
For
and
any
this
instance.
is I haven't tried every OS, but this particular one I'm doing is an Amazon Linux OS. It's not the Red Hat
So
OS.
can we select a EC2 instance? What
Mhm.
underlying operating system should be Red Hat 6, Red Hat 7? Can we do that?
Absolutely.
Yeah, in that case, the naming convention will be changed. Definitely.
Okay. Okay.
Yes.
I haven't observed that. But from the EC2 standpoint, right? Like whenever Amazon Linux, you know what? When I created Red Hat 8 Linux servers, I haven't noticed that.
Maybe you have created Red Hat 7.
Yeah, I created RHEL 8. Okay,
Okay. Okay. Not an
maybe, I
issue.
mean, that's something that you can check.
This is
Yeah.
just an FYI. I'm not just wanting you, just giving
Okay.
information. Yeah.
Okay. Okay. Sure.
Okay.
And then we have the loopback port. Okay, this is the standard loopback port that every OS will have for its own, this IP, right? 127.0.0.0. So that's just the loopback port. Okay. Okay. So that's the ifconfig command. The next one, let's look at, I mean, ping is something that you guys know, I'm sure. Just, do a ping to any
In the loop
particular.
back, please explain MTU just little bit.
Okay, sure. So MTU basically is the maximum transfer unit. That's the maximum packet size. Okay. Um, Typically, for most scenarios, the default MTU size, which is 1500, is what applies for most networks and most services. 1500 is the MTU size. That means you're setting a cap to say your packet size should not be beyond 1500. Okay, that's why it's maximum transfer unit. Um, But in certain scenarios, having a bigger packet size will help. Okay, especially
Okay.
one of the most common scenario for a bigger packet size is your NFS data stores. So if you are like using a NetApp array or an Isilon array, and then creating NFS out of them to present it to your VMware environment as an NFS data store, it is recommended to use an MPU size of 9,000, which is called as a jumbo frame, because the NFS application with data store usage works best with a higher packet size. So in
Yeah.
those scenarios, they recommend both VMware as well as NetApp to use jumbo frames. But otherwise, people just by default it's the 1500 MTU size.
1500 MB, na? Right?
No, no, it's byte.
Okay. Bytes. Okay. Thank you.
So ping command, sure. Ping command, I'm sure you already know. Just once we do a ping basic test like connectivity to a particular IP, if we get a response back, that means it's up. If you don't get a response back, then it needs to be investigated. That either it is not reachable, or it is down, or the IP does not exist. Right. Then the next command is netstat. So when you do a netstat command, right, basically shows you the IP addresses like this and what it is connected to. Okay. So in this case, I have the connectivity from this foreign address, which is actually me, right? I'm connected to this, and it's saying that I'm connected over this port. Okay, it picked some non-standard port, and I am doing an SSH, right? So it is telling that there's a connection, there's an active connection on this particular server over the SSH port, which is your port 22 from this foreign address, okay, over the port 19227. So I am using my 19227 port to connect to a port 22 on the EC2 Linux server. Okay, and there's another command to basically give an hstat space. You give a -an to show the active connected. Okay, so here if you see, right, it will give me. So this is my IP address. So it will also give the A is telling give the active, and N is telling to give the IP address. Instead of DNS name, give the IP address. So here it has given the DNS name, right? Broadband dot. Now here it is given the IP. So this is my public IP. My PC's public IP is this. So you can use netstat
What is the
-an.
170? What is the 172.31.25.227?
That's the EC2 instance public IP, the server that I'm connected to. Okay,
What is the
I'm
port?
not.
What is the port 18368? You said
18368.
on the second, yeah.
Is the local port that is listening?
Yeah, this is the local port.
Okay.
So basically, I am connected through some port, right? So I'm basically, when you're making connection, it can use any of the non-standard ports between 1024 and 65534. Between those range, it can pick any port for establishing a connection.
Mahi, one
And
question. This is the EC2 instance you are logged in, right?
that's right.
This is the EC2 instance from. What is the IP for this?
This is the public IP.
106.15.26.26 or 170?
This one.
So this is okay. Okay. When we
Because
enter ifconfig command, this IP will be shown, right?
no, then if config will show you the private IP.
Right.
It won't show you the public IP. If config will show you the private IP, because they use that natting concept. Remember I told you A public IP is not directly assigned to an EC2 instance like as we see it in this config, but there's a mapping concept that they use.
So where can we check the public IP? Means in the netstat command itself, or is there any other command?
There are two ways. One, you can check it from the console, and two, there is a concept called as instance metadata, where you have to run a curl command against a particular instance metadata IP. When you run that, you can see it. I will show you when we get to the EC2 instance part.
That 106.51.26.66. This is
My
the
IP.
IP of
This is my
your
IP.
IP, means your desktop IP. Your
Yes,
desktop IP.
yes. From where I
Okay, sorry,
connected
your
from.
laptop IP.
That's right.
Okay.
This is my IP.
Okay.
That's why it says, right? Local address means because I'm in the server, this is the local IP address, right? Foreign address is where I'm connected from. I'm outside, right? From where I connected. This is the foreign IP address. And then you can see there are certain
Right.
ports like 111,
Here in the
which is
netstat
nothing is
command,
connected.
we cannot see any private IP addresses, right?
Well, you can like look at this. This is a internal IP, right? So it basically is listening on
Right.
internal some internal ports also,
Okay.
because it will run some internal
Okay.
services also, right? Like for inter-process communication.
Okay.
So you will also see them. So when you see an establish, that means the connection has been established. When you see a listen, that means it's listening on that port and no one has connected to it yet, right? That's what listen means. Okay, so that's about the netstat command. Next, let's look at trace route. One second, guys. Okay, so let's look at the next command, which is trace route. So let's say I want to trace route google.com. So basically, trace route command, what it does is it, basically traces the path, right? Like from my laptop to google.com, it will try to show me every hop that it is doing. So let's say it is going from my EC2 instance to a router or a firewall configured in the EC2 region. Let's say I created a EC2 instance in Mumbai, so there will be some gateway in Mumbai AWS data center. So it will go there, and from there it could probably exit to some service provider that Amazon is using, and from there it could go to some uh, Google router in India, and from there it can then route to again some server in Europe, and then finally to US. So basically, it's doing multiple hops before my connection can go to a server in US, a Google server in US, right? So it will show all the hops it is doing. So in this case, looks like it did almost 11 hops before it could reach the Google server, right? So that's what you can see in the traceroute command. You can see the IP address, right? That it is hopped to, and the latency, how much latency did it take. So far what I'm seeing, everything is okay because it's only in milliseconds. Sometimes you will see that a particular entry will show some seconds, maybe like 10 seconds and 20 seconds. Then you can investigate, okay, why is the hop to that particular switch router device is taking such long, right? Maybe the device is slow, maybe there's some network issue. Then, you basically try to figure out what is going on, right? But again, all of this comes in an on-premise network when you come to Amazon, right? We don't even get to log into any switch, anything, right? It's just, um, if you're seeing any slowness, you either report it to Amazon or you basically create a new instance, or, you try to change your network interface card and then continue working. We usually don't keep troubleshooting unless it is a bigger issue. If you're only having issues with one instance, right, we don't spend our time figuring out why is this wrong, because you don't even have access to check anything, right? You can only do things like this, but you don't have access to connect to a particular device and see what's going on. But overall, I'm just showing you that this is a command that you could use just for a quick you know check as to how the routing is happening.
Mahi,
Okay.
what is the command for trace RT is also for routing
Trace
the
RT is for Windows.
Windows, right?
Yeah,
Yeah.
it's for Windows. And then you have Telnet. Okay, so this particular OS build looks like it does not have Telnet. Let's check another command, nc-zve. nc is not also not there. Okay, so let me install Telnet. Okay, I can install Telnet. I'm going to use the yum installer. Sudo yum install Telnet. Okay, it's installed now. So basically, you can do a telnet space the IP address. I'm gonna pick the Google IP here. So telnet space the IP address to which you want to check the port connectivity to and the port. So I'm gonna do 443. So basically, I'm doing a port connectivity check whether I can connect to that particular IP over port 443. Okay, looks like not. All right, maybe I pick the now the Google IP. So I'm just gonna say google.com and do 443 connected, right? So 443 is the HTTPS port. Okay, that's the standard port assigned to HTTPS. And I know I can connect to google.com, right? So I just tried something which I know I should be able to connect, and I'm connected. Now, if I do a different port, let's say 123, I won't be able to connect because Google will not expose its port 123 for all the users in the world, right? They will only expose, 443 and 80, port 80 for HTTP. Only those they will expose, right? So Telnet is again a good utility that you can use to check the port connectivity, because Ping will only do a ICMP packet check, right? So when you're basically doing a ping, right, it's basically checking the ICMP packets. If we send the ICMP packet to the destination, are we getting a response back? That's what ping command is doing. It's not checking the connectivity over a particular port, right? Whereas Telnet can do that. It can check if a particular port is reachable.
And sometimes the ping is disabled on some machines, so we have to use both ping and telnet. That is the best way.
Yeah,
Troubleshoot.
ICMP is disabled. True. In fact, in EC2 also or AWS, it's a choice, right? You can either enable ICMP packets or you can disable it. If you disable it, ping won't work. Okay, that's
My
Telnet.
NC minus VZ or Nmap, these utilities are legal, or means can we use that utilities?
Yeah, some OSs they come with that, and it all depends upon your build team or your security team, right? Whether they want to
Yeah.
include that in your OS.
Okay.
I mean, what I've seen is, I think CentOS has NC minus ZV by
Yeah.
default.
But most of the Red
Um,
Hat and SUSE, I think, don't have because of the security reasons.
yeah, I
We
mean,
have to
like I said,
install manually.
right. It's a choice, right? Telnet
Yeah.
obviously is more famous one. You
Telnet
also
is,
have the Telnet in Windows, right? So
yeah. Yeah.
you can use Telnet.
Okay.
Okay. The next command is nslookup. So nslookup stands for name server lookup. That means if you want to check the IP address for a particular DNS name, basically when you do nslookup, right, you're doing a DNS query. Okay, you're calling the DNS server and saying, hey, give me the IP address for this particular DNS name. Okay, so for example, nslookup google.com, right? So when I did the nslookup google.com, this is the DNS server it queried against. So this right here indicates which DNS IP did this query went to. So it looks like it went to 172.31.0.2. Okay, and the answer that we got is this. So this looks like is one of the IP for google.com, and this is IPv4, and this is the IPv6. Okay, so it basically gives you the name to IP details. Similarly, if you want to get the IP to name, right, we call it as reverse DNS lookup. So the forward DNS lookup is name to IP. If you want to get IP to name, that's called as reverse DNS lookup. You could also do that, provided, okay, Google allows it. So not every entry is by default reverse lookup. So basically my point is, name to IP is one entry. So you could use nslookup the name to give the IP, but IP to name is not mandatory. So it doesn't mean that once you have name to IP, you can resolve IP to name also. There should be an explicit record for IP to name also in the DNS if you want to do a reverse DNS lookup. Let's check if I can do that here. See, I got it, right? So I was able to do a reverse DNS lookup to get the DNS name for this one. So it looks like this is, I think it's getting it from Bombay. There's a Google server in Bombay, and I think I'm resolving to that Google server. So yeah, so basically this is the forward
It
DNS lookup,
should,
and this is the reverse DNS lookup.
Mahi, it should give the google.com name, no? Instead of giving this name.
I don't think they expose it as google.com domain at the end.
Right.
Yeah, I don't think they do that for
Maybe
security
they
reasons.
expose the one of the aliases.
Yes, exactly.
And they have
Okay.
explicitly written the IP2 names entries in this DNS
DNS
database,
server.
right?
Yeah, those records are called as PTR records. So a
Yeah, pointer
PTR
records, A
record,
record, PTR record.
yeah, PTR record is what you use for reverse lookup, and that's an
Right.
optional field. Okay, it's not mandatory that you need a reverse lookup. It's optional. Again, we're going to
Most
discuss
of
more
the
about
time, A
DNS and
record
all
is used, right?
in Route 53 service. We'll be discussing about more about the DNS and how
Yeah,
what are the
sure.
type of records and everything. Okay. All right. Yeah. So these are some of the commands. I have some links in my document that I'll be sharing. There you will see, even more commands, so you can like practice around and come back if you have any questions. Okay. All right. So with this, we are done with our network basics. Now let's get on to the Linux basics. All right. Let me reshare my screen. Okay, I'm resharing my screen. All right. Okay, you should see it now.
'53 service, we will be discussing VLAN and all these things, right?
VLAN we'll be discussing in VPC.
VPC, okay, VPC, yeah.
Yeah.
Okay.
All right. So Linux basics, right? Just a quick history background check. Okay. Um, I'm sure you guys know all of this. I'm not gonna bore you completely. We'll skip this soon. Um, so prior to like a few decades back, right? If you're in the 1980s time, that's when Linux is like started really picking up. One of the core strength of Linux or Unix being its community and open software, right? That has really helped Linux to come to a state where it is right now. Now if you compare to Windows, right? Windows was more license based and only restricted, but only Microsoft controlled any development activity, features, etc., that would go into it. Whereas Linux, on the other side, it had a huge community strength. People from around the world were developing tools, utilities, and you know, there's a lot of contributions that was coming, and that really helped the whole community to grow and to come to a shape where it is right now. Now, in Unix, right, you have different flavors, right? You have Linux is one flavor, and you have AIX, you have HPUX, you have Solaris. Again, I'm only listing the more popular ones. There are, I think, Wikipedia says there are more than 1,000 distributions of Unix. Yeah, like different ones people have created. Um, I think the popular ones probably will be 20 to 30. Okay. But there are a lot more distributions that were created by different communities. So these are the different flavors of Unix. Okay. Um, Again, within Linux, right, you have so many. You have Fedora, you have Ubuntu, you have CentOS, Red Hat, um, SUSE, right? There are so many flavors again within Linux as well. So our focus here is gonna be in the Linux because the other ones, right, is something that AWS does not support at the moment because the hardware that is needed for like running AIX or HPUX or Solaris, although you can run Solaris on a x86 system, like a Intel based system, you can still run Solaris, but it's not quite there. Okay, so basically for running these other operating systems, you need to have a specialized hardware. Like for AIX, you need to have a P series. For Solaris, you need to have a Solaris T series model. So they have their own architecture. They don't just run on a regular Intel-based servers. Okay, so for those reasons, Amazon, at least today, they do not have support for these other Unix flavors. Linux is, the most standard OS that they support, and within Linux, again, they have so many flavors that I just stated. So you can pick and build what you want. Again, all these flavors, right? They really vary from a couple of things. One, um, there is certain distinguish between different flavors. Like for example, Red Hat and CentOS kind of use the same kind of Linux kernel, okay? And their package managers like Yum is the same between them. But when you compare this with a Fedora, right? Their Linux kernel is different, slightly different. I mean, it's not completely revamped, but it's a little different Linux kernel. Um, and the package manager they use is also different. They have a different package manager. It's not Yum. So things like this is what will vary between different flavors of Linux. Now, even within Red Hat and CentOS, there are again few things different because Red Hat, for example, I'm just giving an example. Red Hat could have Telnet utility as part of its plain vanilla build, whereas CentOS may not have it because CentOS owners may have um, assume that they will use NC as the equivalent of Telnet versus the Telnet itself. And Red Hat has decided, no, no, no. My customer base is asking for Telnet utility, so I will build a Telnet into the OS instead of NC. So these are things that will be different. But the overall, if you see the interaction is almost the same. There will be certain commands that can vary between each of these flavors, but the overall working and the backend kernel is almost the same. So if you know how to work around with one OS, you will, to an extent, you know how to work around with any Linux OS. Okay, it's just those commands that can vary, a little concepts that can vary from flavor to flavor. Okay. Now, in fact, Amazon has its own Amazon Linux OS. They had a version 1, and now they have version 2. So, like anyone can come up with their own version of Linux because this Linux kernel is open source, right? So anyone can use the Linux kernel, provided there's basically some agreement that you have to get into with the Linux community, and once you get into that agreement, you are able to use the Linux kernel and then build your own OS on top of it. You can name it whatever you want, right? So out of these all these different flavors, there are certain that are available for like an open software which you can deploy, and there are certain which are licensed as well. Like for example, Red Hat is one of the famous Linux vendor who licenses their software because along with that they provide multiple additional features. They provide support, right? They'll have a Red Hat support team. So because they are providing you those enterprise features, they have to charge you for it. That's where the cost, for the licensing comes from. But if you look at Ubuntu, right, there are two models actually for Ubuntu. There is a free and then there is a enterprise support model. So if you go for the free model, I mean, you can just download Ubuntu and install it. Even CentOS, you can just go download CentOS and install it. No one is stopping you. But if you need support for like Red Hat, right, then you need to go for a license and some enterprise agreement. I mean, if you pick any enterprise, usually they go with the enterprise license because they need support. But if you're just doing some tests, just installing it for practice, then you don't have to. Okay, so just a quick background around Linux. Now let's get into some of the concepts. Okay, let's start with um, I'm- I think you guys are familiar with like logging into a Linux server and like just getting yourself familiarized with the Linux server. Is that something you would like me to cover or you're aware of it?
I'm aware of it.
Okay. What about Danish?
Yeah, I am aware of it.
Okay. All right. So I'm not going to get into those basics then. I mean, CD and creating directories. I think you guys are familiar with those things.
Yeah.
Let's spend some time on permission management. Are you guys aware of permission management in Linux?
Yes, like file level permission and directory level permissions.
Yeah. And sudoers.
Yep, a sudo used for root user.
Yeah. Okay, Danish.
But there are some critical permission like ACL and sticky beat. We have to go through it, I think. Right.
Okay. Yeah. I'm not going to cover in that detail though, because I mean, this is just
Yeah,
basic.
you can
But
cover means as you want. Then we will go through
okay.
it or offline.
Okay. All right. So quickly on permission management, right? So basically, we have the concept of users, we have concept of groups in Unix, and every user will have a UID, every group will have a GID. And within a particular Linux system, the UID GID has to be unique, right? Um, by default, Linux will assign a UID GID when you're creating the user and a group. But if you want a particular number to be as a standard, right, then you can always pick that UID GID what you want that particular user and group. Um, in terms of permissions, when you're creating a user, you have to assign a primary group, right? And you can have additional groups as well. For example, let's say I want to assign a user um, a group permission. So let's say there's a user called Mahi, right? And I want to create a group called Mahi group. So I want to assign Mahi group as the primary group for my Mahi user. So you can do that, right? That is the primary group. But apart from the primary group, if you want the same Mahi user to be part of multiple secondary groups, you can also make that happen. Maybe you have another group for sales, have another group for finance, right? Because you want certain permissions that are assigned to the sales team also assigned to your user so you can access those files. Maybe you're doing some scripting for them, maybe you're doing some automation for them. So you need to access the files that are owned by that group. So that means your user has to be added to their group, right? So that's the user and group thing. In terms of sudoers, basically all sudoers is doing is it is elevating your access. Because I mean, you can say, hey, I mean, if I want my access to be elevated, why can't I just use the root account? Yes, you can use root account if you want to have a consistent, um, you know, uh, full access to the system like administrator in Windows. But then having root always is not good, right? Because you could do few things which can actually break the system. So to keep them separate, Linux has this concept called sudoers, where for most of the time you're just running as you, as my user, let's say. But if you want to elevate yourself as root, you can do a sudo command before the actual command that you're running. Because certain things are restricted to sudo, and then you could run that particular command. Right? With that, basically, now whenever you're using sudo, you know that, oh, I am doing some elevated privilege command. I have to be extra careful on what I'm doing, right? Again, all of this will only work when your user account is in the etc sudoers file, right? So that sudoers file needs to give you permission that, okay, this particular user called Mahi is allowed to elevate as root when needed. So that entry needs to be in the etc sudoers file. What is permission management? You guys know about the that read write x, right? 755 those permissions.
Yes, user groups and others.
Yeah, and then the ownership also. Who's the
Yes.
user? Okay, owner and group owner. Okay, perfect. Then let's talk about file systems. Okay, let's talk about file systems. Um, the basic concept of a file system is very similar to how a drive is in Windows, right? You'd have a C drive, D drive, E drive in a Windows. Similarly, you could have a file system like, slash boot and slash temp and slash U01 data file system, U02 data file system. These are very similar to your drives in Windows, right? Um, One difference though is in Windows, right? Let's take an example. Um, my requirement is I need two drives, each of 100 GB, C drive and D drive. So I will assign two disks, right? Each of 100 GB to the Windows server, and then from the individual disk you create a drive. So it's a one-to-one mapping. You have a 100 GB disk, you create a C drive of 100 GB. You have a 100 GB disk again, you create a D drive of 100 GB. It's a one-to-one mapping. But when it comes to Linux, right, it can be a one-to-one mapping. There's no one stopping you. But for flexibility's sake, okay, people use something called as LVM, Logical Volume Manager. You guys aware of it?
Yes, like I know like logical
Yeah.
volume manager.
Okay. I think we should still go through it because I may add a few points that may help. Okay, so I'm gonna still go through it. Okay, what is this? All right, LVM. So with LVM, this is basically another utility that is available in your Linux OS. Comes as part of the operating system. As the name itself indicates, it's the manager that manages your logical volumes. And logical volume is your file system, right? So the first step is we will assign some disks, right? Some raw disks to your OS. Those are called as, depending upon if you're using virtualization, virtual disks or physical disks, LUNs, right? They have different names to it. When it comes to the LVM, when the LVM looks at that disk, right, it is now called as a PV, a physical volume. So we call it as a PV. So once you have the PV, we need to add this PV to something called as a volume group, VG. So volume group is a container, okay, that will contain either one or more PVs. It should have at least one PV, okay. It can have more PVs also. So let's say I have two PVs, each of 100 GB. I've created a volume group and I've added these two PVs to the volume group. So now I have a volume group of 200 GB. There's 1 minute. Okay. So I have a volume group of 200 GB. From the volume group, I create a logical volume. So this logical volume it depends, the size of the logical volume depends upon the size of the file system that you want to create. Maybe you want to create a root file system where you will install your OS and basically like a C drive, right? Your root file system. You will create it of size maybe 50 GB, right? So you can create one LV, maybe root of 50 GB. I still have 150 GB left. Maybe I'll create another data file system called U01 of 100 GB and then another data file system U02 of 50 GB. I can only create up to 200 GB, right? Because that's what I have in my volume group. I can't go beyond that. So these are the file systems that I will create. Logical ones that I will create. Come on. So once I have the logical volumes, right, you have to convert them to a file system, right? Like in Windows, we are familiar with NTFS. Now you have REFS also. That's the latest file system type available from Windows, REFS, NTFS. So similarly, in the Unix world also, you have different file systems types, right? The famous ones being ext3, ext4. Now you have XFS, right? So these are the file system types that you use. So we have to convert this logical volume to a file system by providing a particular file system type. Because once you create a file system, is actually when the OS is actually taking ownership of this logical volume, so that now it can maintain, the inode information and the physical data, where it is written for every file. So it has now taken ownership, complete ownership of the file system, and then it will lay out that inode table and figure out, okay, this file is in this location on this disk, etc. Right? So once you have the file system, now you have to give it a mount point, right? We have to give it a name, like slash, like U01, like U02. You create a directory with those mount point names, and then you attach that file system to this mount point, like how you do a C drive for a particular drive in Windows, a D as a drive name to a Windows. Similarly, we map these. Now, the advantage that we are getting with going for an LVM versus a one-to-one mapping, right? Like, for example, you could just create a 100 GB disk, and that 100 GB disk is going to be a root file system slash, and your other 100 GB disk that will be a slash U01 file system. Okay, the disadvantage with that and the advantage with using LVM is like if you want to have I don't know, like a 20 terabyte file system, right? Um, there are certain limitations that we know we have from a storage side, right? That a single LUN cannot be as big as 20 terabyte. You know, it's not recommended. We should have maybe 2 terabyte LUNs, 4 terabyte LUNs. So in that case, if you want a 20 terabyte file system, you can't do it without LVM, right? You can't attach a 2 terabyte LAN and create a 20 terabyte file system. But here, what you can do is you can create 10 such 2 terabyte LANs, add it to the volume group, and now you have 20 terabyte in your volume group. Now create a file system of 20 terabyte. So basically, what you're doing is you are uh, concatenating multiple LANs to form a single file system, right? Similarly, you can also do partitioning. Because typically in Linux, we see that there are a lot of file systems with different varied sizes. One could be 1 GB, one could be 200 GB, one could be 5 terabyte. So you have different files on different sizes. So you don't want to create a small LUN as 1 GB to create a 1 GB file system, right? But with this, you add everything. Let's say as a standard, you create 2 terabyte or 4 terabyte LUNs. You add all of them to the volume group, and now you have a container that has X amount of space. Or just keep creating LVs of whatever size that you want: 1 GB, 11 GB, 2 terabyte, whatever size. It makes it more easier. Also, from a Unix administration standpoint, it becomes much easier for your admins. That's why we use LVMs. Guys, any questions?
No, and this volume group can be expandable, right? When if you want to expand.
Absolutely. If you need more space in the volume, you just create a new PV and add to it.
Okay.
Okay. I think I have where is this? Quick link. So let me share this. We can quickly go through this.
And Mahi, what kind of file system that Amazon instance will have supporting?
They do XFS.
Okay.
Yeah.
And what kind of LVM version they have? LVM 1.1 or LVM 1.2?
Actually, Amazon does not use LVM.
Okay.
Yeah,
So
it does not use LVM.
so they do not use LVM means they are using the standard disk and
Yes.
creating file system on one-to-one mapping, right?
Yes.
But that is
With
not a
Amazon Linux OS.
standard. That is not useful, right?
Well, I mean, there are other things that you
Yeah,
can
means
do in
ideally, most of
Amazon. No. So basically, there are other things that you can do in Amazon, which you can work around it actually. Because now we are not talking about. See, that's where I guess I have to prepare you guys to say the way we do it on-prem and the way we do things on cloud is going to be different. The concepts that we are used to in on-premise with, let's say, limitations around number of LANs, LAN sizes, etc., they don't really apply when you come to cloud. They're more flexible. So these concepts, uh, does not one-to-one occur in cloud. Okay, so you'll understand when we go to that particular service.
just one question. For example,
Mhm.
we have created, we have assigned one disk, for example, of 1 TB
Okay.
from cloud, and
Hmm.
that 1 TB is almost full, but I want to extend that drive only 1 TB.
Okay.
Can we do that?
Yes.
I don't want an extra disk.
Yes.
I want to extend that disk only.
Yes,
which is having 1 TB of data.
absolutely. You can do that.
Then we have to extend the file system as well.
Yeah. Although some
But
vendors they
with the
don't
normal
recommend on the
Linux,
go for it. Sorry.
yeah, I'm saying that with the normal Linux, for example,
Mm-hmm.
if we provide one disk, for example, and we are not
Right.
using LVM, and that disk is
Mm-hmm.
containing, suppose, having data of 1 TB, and disk
Uh-huh.
size is also 1 TB, and data is of, suppose, 999.99 GB, and the disk is
Uh-huh.
almost full, and we
Right.
want to grow that disk. So what will we
Uh-huh.
do? We will expand that disk from storage end first, right? Suppose we have expanded that disk 1 TB to
Mm-hmm.
1.5 TB, correct? Now it is
Okay.
expanded from the storage side. How can we
Right.
expand that disk from server side? Because when we resize that disk, we have
Mm-hmm.
to extend the file system as well. Is it supported?
Correct. So it all depends on the OS that you're talking about, right? Because some OS vendors they are okay with it, some OS vendors they are not. But from the AWS standpoint, you are able to increase the disk on the fly. You can increase it from 1 terabyte to 1.5 terabyte on the fly.
So when we increase the disk, the file system will also increase on the fly, right?
No, 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 no.
We
Only
have
the
to
package
increase
disk is increasing.
manually.
Correct.
Yeah, so in that case, we have to increase it manually, right?
Exactly. Exactly. Because
Why
Amazon is
I'm
not
asking that
managing
question
your
is because the steps
OS.
to increase are very critical. We have to use that.
Correct. No, so Amazon is not managing your OS, right? It is giving you the OS. It is giving you the disk. It is giving you the network. It is giving you the CPU memory, but it is not managing your OS. That is up to us. Like, do we want to go with that, or whichever is the best approach? Like you said, right? Obviously, it's not always recommended to resize an existing disk, right? So Amazon is not managing that for you. That is how you want to do it.
Okay.
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 All right.
Yeah.
There's a quick
When we
link.
go to that part, discuss in detail. Yeah. During the disk expansion.
Okay. So here's a quick link that just outlines what I discussed about LVM. So first when you get a disk, right, you would do a fdisk minus L. So fdisk is another utility that can manage your raw disks. So fdisk minus L, and then the disk path, right, will give you if the disk is available, right? Or if you do an fdisk minus L without this, it will list everything. And then you can partition the disk using fdisk. There are certain commands that you can follow. Um, you know, um, N to create a new partition, P to provide the partition number, and then finally W to write the partitions that you have created. Because you can actually break down a particular disk into multiple partitions as well. And then once it's done, you can start creating your physical volumes. You can then add your think he's not shown the step for creating a VG, but he's already created a VG. So he's created the PV, and then he's added the VG to that, or he added the PV to the VG, and then he's created the logical volume, and then he's creating the file system from the logical volume, and then he's creating the mount point, and then he's created an entry in the etc tab. Right, this is the file that we use to keep the mount persistent, right, across reboots. So once it is there, run the mount command, it will mount everything. So now you should see the file system. So yeah, it's a quick one there. Okay, so that's about the LVM. What else do I have to cover? The basic commands of Linux, I think you guys are
My
familiar
my
with, so you could, yes.
my. Uh, this is the command to increase or extend the disk, right? But this is the
Which one?
part of LVM. When your disk is part of LVM, we can extend that drive, that SDB, right?
Uh-huh.
Can extend.
Uh-huh.
We can reduce. Generally, we cannot. We can reduce, but it's risky. Uh, but
So
when the
you
disk is a
reducing the file
part of
system?
LVM, yeah, we can reduce we can reduce it.
Yes.
First, we have to reduce the file system and reduce the disk. LV reduce using.
Yes.
Yeah, this is the case with the LVM, right? But
Uh-huh.
I'm saying if the disk is not part of any LVM, it's a raw
Right.
disk,
Okay.
then can we extend that disk? We can extend from storage. That's
Yes.
fine because
Yeah.
storage doesn't know what kind of file system the learner have.
Right.
But we can increase from storage from 1 TB to 1.5.
Right.
But that disk has not been still yet reflected on server side. We will rescan it. It will show 1 TB to 1.5 TB in F disk, but we have to increase that file system from 1 to 1.5 TB using resize to FS or XFS grow FS. But will that command will work in case of raw disk, which is which is not part of any LVM? That is my
I
concern.
I think with Amazon Linux, I've tried that. It worked.
Okay, then great.
Yeah. Yeah.
Which is not part of LVM.
Yeah. It's not Amazon Linux OS by default. It does not have LVM.
Great.
Yeah. Yeah.
Okay, thank
Okay. So the other things I think you guys are already familiar with. We don't have to spend a lot of time on any of these. Let me know if you feel like we need to cover any of these other ones. Just have the permission management, basic Linux commands, in file systems we already covered, LVM we covered. I think we can skip this, right?
you.
Okay. Okay. One more thing, quickly on the networking part. There's a directory that I wanted to show you guys. Okay. So usually, right, for Linux OSs, the directory where all the network related files are stored is this directory, etc sysconfig network scripts. So here you will have a lot of different files. So there are like different
Mahi, I
files.
cannot see screen. I can see only ETC address tab.
Oh, okay. Let me reshare. How about now?
Mm,
What do you see
Just,
now?
just a moment. So I can, just a moment.
Okay.
Just a moment.
Binit, are you able to see?
Yes, I can see.
I can see the Word document, AWS training docs.
Okay, and Binit, you see the terminal, right?
Yeah, I can see the terminal.
Maybe my
Mm, okay, let me try it again. Let me try to stop and start sharing again. Okay. Okay, what about now?
I cannot see. Go for it. I know that file. It is this is config network. Yeah, you can go.
Okay. So here, there are these files which start with if CFG. Okay. So in this case, if CFG ETH0, loop back port. So this particular file is what will specify like the IP address and what is the MTU setting, what is the MAC address for this particular NIC card or Ethernet card. So if I do a cat on FCFG ETH0, it will give me these details. So here if you see, it says DHCP is equal to, yes, see?
Hmm.
So when it says DHCP is equal to yes, that means it is getting the IP automatically assigned, because DHCP is the protocol that assigns the automatic IPs, right? So that's the DHCP part. And then you can see on boot is equal to yes. That means even when you reboot your system, the configuration of the interface should automatically come up. So that's what you're specifying there. If it was a static IP assignment, you would have seen an entry for the IP address here. But since it says DHCP, you won't see the IP because it will automatically be assigned um,
So
by
can
DHCP.
you edit these files?
Yes, you absolutely can edit this file. For example, if you don't want to, um, like have DHCP configured, you can, comment out the DHCP, and then you can add an entry called IP is equal to the IP
Hmm,
address.
okay.
And there's some concepts, if you are familiar with bond configurations, like port channel,
Yes.
LSCP.
No, not much.
Okay, okay. So like, I mean, it's simple, right? Like if you have two interfaces, ETH0 and ETH1, and you want to bond them or combine them to form a logical interface, like combine those two to form a logical interface. That's called bonding, right? LSCP, port channeling are different types of bonding. And there are different modes. There is mode 1, there is mode 4. Mode 1 means active passive. That means only one interface will be, active at a time. Mode 4 means active active. So both of the interfaces can, serve the connectivity and data transfer. So all those configurations you can do it here. Also the MTU setting. So right now, if it is nothing is there, that means MTU size 1500. Now, if you want to have 9000 MTU, you can set it here. Say MTU is equal to 9000 and your Jumbo frames is enabled. So this is the file where you do all that.
Where can
Okay,
we
all right.
see NAT settings or bridge settings?
NAT bridge. Let me think. NAT settings. You're talking about like the NAT server details?
Yeah, NAT server details, or we are using server. If this server is communicating with the router, or the ISP using NAT, or using bridge, or using host network.
That I'm not sure. I haven't explored that part. It probably should be in the same, network scripts. There are a
Yeah,
lot of
I
different
will.
configuration files.
Okay, I will check it and I will get back to you.
Okay, okay, awesome. Alrighty. So that's about the Linux basics. All right. So let's get on to the AWS introduction. All right. So let's go back to the presentation here.
Mahi, give me 1 minute. I am reconnecting because I am not able to see your screen.
Okay, go for it.
Just give me 1 minute.
Sure.
Please share your screen.
Okay. Right. Can you see it now?
You can see blank document.
Yes.
Okay. I'm sharing my PowerPoint.
Yeah, I can see your PowerPoint.
Okay. Maybe Dhyanesh, can you also join from your mobile, GoToMeeting app? Maybe you can use that for screen share.
You are saying using mobile.
Yeah, you can download the GoToMeeting app and key in the meeting ID.
Yeah. Just give me
Okay.
1 minute. Just okay. We can take the break
Yeah.
of 1 minute.
I'm just gonna talk about it, so I'm not writing anything. Okay. So, um, Amazon, as we know, is one of the cloud service provider, right? As a cloud service provider, meaning they are providing different services to us, basically they're providing services to us, right? A service could be as simple as, uh, you know, they're providing some storage to us so we can store our data, files, application related, or personal files, etc. Or it could be as complex as they're managing our databases, or they're managing our networks. They're managing your uh, code, right? So it could be any service. So depending upon your requirement, you go pick a service that meets your requirement. Like it's like how we go for a dinner at a restaurant. We have a menu card. You have all the different options. You pick what you want to eat. Same thing. They have a lot of services, and you just pick the service that you want and that meets your requirement. Amazon has close to 250 300 services. Um, but then the most core services, right, the one that actually are used by a lot of enterprises, right, for their day-to-day activities, for running their applications, database, etc., are some of them. And those are the services that we will be focusing upon in this particular course. Now, the other remaining services, they have a very specific requirement, right? They will only work for that particular requirement. So those we will not be covering. Okay. I mean, as an example, there is one service for Alexa where you can create your own app for your business or for like a game, so you can deploy that in Alexa and people can use that app. So it could be as specific as that, or it could be a broader service like the EC2 service, which is one of the most important service, where people can create different instances or servers. Where once you have a server instance owned by you, you can basically run any application, any database that you want, right? So how is Amazon able to do all of this? So the geographical setup of Amazon's cloud is one, it is across the globe. They have presence in all the premium, regions, okay, like where you find a lot of businesses, either it be your US East, US West, your Canada, in Europe, Australia, India. They, in fact, have their presence in Africa, South America. So, like pretty much across the globe in different regions, they have their presence. Now, obviously, when we talk about cloud, right, it is not an imaginary world where just things just come in, right? Obviously, there needs to be some physical infrastructure which is supporting the cloud, and that physical infrastructure is what Amazon will set up, right? Like in India, Amazon has a region in Mumbai. Okay. So now we are talking about different terminology specific to AWS. Okay. So AWS has something called as regions. They have, I think they have 11 regions now across the globe, not including the government regions. So there are certain regions that are dedicated to government institutes. I will talk about those later. But the regions that are available for everyone are 11 regions. Um, every region will have something called as a availability zone. In short, we call them as AZ. Okay, every region will have availability zones. Now, it could have multiple availability zones, minimum two, okay, and you can have more. So based upon the region that you're talking about, you can have different number of availability zones. As an example, Mumbai has three availability zones. Um, North Virginia in US West has six availability zones. Yeah, it's US East. I'm sorry, it's US East. Six availability zones. So each availability zone is representing a data center. Okay, and a data center is again pretty huge, because it's Amazon, and there's so many businesses that use Amazon at the moment. So their each data center is not a single building. They could have blocks and blocks of data centers. All of that is called as one availability zone. Now, but the reason they have multiple availability zones in a region is for availability and having that fault tolerance. Because if they had just one facility of a huge data center, and if something happens, maybe some geographical disaster, a flood, earthquake, some riots happen, something happened, right? Then they will lose all of it, right? So instead, they have split their infrastructure within the region across multiple availability zones, so that if something happens in one availability zone, the chances of the same issue, like some geographical disaster happening in the other availability zone is lesser. It's not that it cannot happen, it's lesser, because they will make sure each availability zone is separated by some distance, maybe by 100 miles or a few hundred miles. Okay. So in Mumbai, they have three availability zones. Okay, each availability zone represents a data center, and all these availability zones are connected with super high-speed networks, because they are all interconnected. Because when you run your applications, your servers, etc., right? You want to have, for high availability, your servers spread across multiple availability zones, and they both have to interact with each other. Then you need to have that kind of a bandwidth, right? So for those reasons, they will try to, have very high-speed networks between the availability zones.
Mahi,
And
how
obviously,
far they from? Sorry to
go ahead.
interrupt you. Mumbai region has three availability zones, and what is the distance between them?
Uh-huh. Well, it depends. I don't think they publish that anywhere,
So
but
means
they're
they have not
separated in
published.
such a way that the if something impacts one availability zone, the chance of impacting the other one is lesser. Plus, obviously, they need to have real estate for it. You know, the land should be available. They should be able to lease it. So all those factors considered, they will figure out, what's the best distance.
Means
Like,
they have designed. Suppose someone has to design, then they must have given the specification that distance should be there, like 100 kilometer. The availability zone should be separated, or 50 kilometer, right?
correct, correct.
So what is that distance, minimum distance or the maximum distance that AZ should be separated from?
I don't think they've published that. At least I have not read that anywhere. But what they say is our goal is to ensure that each availability zone has a separation enough to handle any geographical disasters or any unexpected situations like riots or anything.
My question here is, suppose in Mumbai, in Worli,
Hmm.
suppose uh, there is one DC, and
Okay,
we will have three DCs apart from
right.
Mumbai, right? And these are
Uh-huh.
called AZs, AZ1, AZ2, AZ3. AZ1 is in Suppose Panvel AG2 is in Sangli, AG3 is in near about your let's say Pune,
Okay.
right? So these are separated from some distances, right? So there will be three
Right.
DCs, and the
Uh-huh.
actual primary data will be in Mumbai, right?
No, no, no. So the data will actually be in one of these DCs. When you're creating a server or when you're creating your storage, they're actually specifying which DC you would like to create them from.
Then what is in Mumbai?
So your region, okay, your availability zone is the physical entity. That's the physical data center.
Right,
Now, these three availability zones together is called a region, which is Mumbai. The logical aggregation of these three availability zones is called as a region.
right.
Okay.
Got it. All the data is replicated between three AZs, and
No, 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 no. It does not have to be replicated. It can be replicated, but does not have to be.
yeah, it doesn't have to be. It can be replicated depending upon
Yes.
how the data is critical, or depending on the requirement
Depending
you want to
upon
set.
what service you pick and what policy you would like to, go for, right? Because
Right.
for some you don't want to spend that additional money. You don't need a replication.
The data will be stored in only one AZ or in two AZ, depending on
Yes,
requirement.
exactly, exactly.
Okay. Yeah.
Okay.
And can we
So
choose a
so that
region as Mumbai and AZ
mhm.
as Virginia, South Virginia?
No. If you're picking a region, right, that means you want to select an AZ in that region,
Right, right. Okay.
right?
Yeah. Right.
Um, so that's the ASEAN. Like I said, minimum two AZs will be available in any region. Um, but it depends. Like North Virginia is one of the oldest regions. That's the region where they started AWS with, and they've like grown to six availability zones now. In fact, Mumbai, a few months back, I think 6 to 8 months back, they had only two availability zones. Now they've added the third one. So it can keep growing, right? Depending upon the usage and how popular it gets. Another thing, there are certain services that may not be available in every region. Okay, certain services could only be available in particular region, and it may not be available in other regions. So I mean, Amazon in its UI, it shows that, like when you're going to a particular service, right? They kind of black out certain regions, and the reason you will see that is because in that particular service is not available in that region. Okay, so that is one. And usually, like when they are rolling out a new service, right? Um, they roll out it in North Virginia. So I mean, in fact, for our practice and all, I would like to use mostly North Virginia. Sometimes I use Mumbai, um, because in North Virginia you will have every service, and any new service that they're rolling out, they usually tend to roll it out in North Virginia, and then slowly like they roll it out in the other regions. And North Virginia is the biggest of all the regions. Now, apart from these regions and availability zones, they also have something called as edge locations. Okay, they're called as edge locations. The value of an edge location is mapped to a service called as CloudFront. There's a service in AWS called as CloudFront, which is helpful as a caching service. For example, let's say you have some storage repository that you created in Amazon. There's a service called S3, simple storage service. You can create a storage repository like Google Drive, like Dropbox. It's a service, okay, from AWS. So you created that and you stored some media files in there. Okay. Now, if you want to access those media files which are there in S3 in North Virginia, but you are in Mumbai, right? Or you are in India, So, and multiple users wants to access those media files. So obviously everyone has to go all the way from India to US every time to access every media file, right? Instead, you could use this concept called CloudFront with edge locations. So what Amazon has done is they have created these smaller data centers called edge locations in multiple cities. Okay, in Mumbai, in Hyderabad, in Delhi, in Chennai, in Bangalore. In India, they have like all these cities they've covered, and within the city also there are multiple edge locations. Like in Bangalore, I think there are three. In Delhi, there are four. Hyderabad, I think there are four. So they have multiple edge locations. So now what happens is if CloudFront is enabled for that storage in North Virginia, the first user who's trying to access from Hyderabad will obviously have to fetch that file all the way. But the second user, when he's trying to access, the CloudFront service will try to cache that file in a local edge location in Hyderabad. So the next user is trying to download the same file does not have to go all the way. He will download it from the nearest edge location. So for those reasons, okay, Amazon has these edge locations also that they have built. Again, these are relatively very smaller data centers. They will not run services. All they will do is caching. That is all they do. They don't provide any services out of those edge locations. If you want to use services, you have to use the availability zones only.
And the cloud front should be enabled on that region itself, on
Particular
the for that service. Suppose
for that
we have
service.
region at South Virginia. On that
Yes,
South Virginia, we have to enable that cloud front service.
correct.
So we have to enable that cloud front service for that region, or we have to enable that service for instance.
For that service.
Didn't get.
So I think you will understand this better when we talk about
For
S3 and
example, there is S3 service which is
yeah,
using the storage repository. For that
right.
S3 service, if we want the data to be retrieved fastly, we have to enable that cloud front for S3 so that we can retrieve the data using edge locations,
N-
for example, from
Not even
Hyderabad.
not even S3 actually. Within S3 we create something called as buckets, which are like your folders. So for a particular bucket, you have to enable it.
Yeah, for example, there is a suppose 15 TB share. Out of that, there will be folder of 2 TB, 1 TB, or 100 GB to 100 GB each folder. For example, bucket 1, bucket 2, bucket 3. So we can enable that cloud front for edge folder level as well, right?
No. Okay. I think we should discuss this when we get into S3 because it's not,
S3.
like I said, right, like on-prem and when you come to cloud, it's not exactly the same. So yeah. So
I'm just
I
sharing
want to
with
make sure that I'm not confusing you guys here because I want to I want to make sure I provide you the foundation and then take you there because the terminologies that you just used, Dhyanesh, are not right.
okay.
Yeah.
I'm just what I understand is we have to enable that service. We have to enable the
Uh-huh.
cloud front at particular service level.
At a
We
particular
can enable.
service and a resource level.
Yeah, service and resource level. Okay.
Yes. Okay. So that's the edge locations part. Now I'm going to show you a quick map from Amazon, which has all these like like a global map, right? They have all these laid out. So let me share that. Okay. So yeah, here is a map that shows all the regions. So if you see, right, there are so many regions that are available across the globe, and you can see them spread across. All the blue ones indicate the existing regions, which are already, available for service. The orange ones indicate the ones that are coming up. Okay. Now, some of these, like for example, the um, this one, right, the AWS Cloud. These regions are not available for regular customers. because those are restricted to only the federal agencies or the government agencies. So we don't even see that in the console. Now the other regions, as you can see, for every region they will show how many availability zones are available. Like in this case, there are 3 availability zones. Let me show North Virginia. There are 6 availability zones. And in Mumbai, there are 3 availability zones. It also shows when they were launched, right? And then there's in Cape Town, there's coming up. Bahrain and Spain, I think they're coming up. Oh, Bahrain. Oh, Bahrain got launched. Okay. See, this wasn't launched. I think I checked this a few months back. Bahrain was not available. Now Bahrain is available. 2019, it's new. There's one in Australia. Jakarta is coming up. Yeah, even Hong Kong wasn't there a few months back. It just came up. So yeah, they're spreading across the globe, growing. So you see all of that, right? And so that's the reason and the availability zones. Let me show you the edge locations. I think I don't have the link. Let me look it in Google. Okay. So yeah, these are all the edge locations as you can see by continent. Let's go to Asia. Okay, here it is. Edge locations, Bangalore, there are 3. Chennai, there are 2. In Hyderabad, there are 4. Mumbai also has 3. Delhi has 4. So just in India, you have these many edge locations, plus Hong Kong and other ones in Asia. They also have other edge locations. So these are like the focus of these edge locations is for those caching because some of these areas, right, there are like prime areas where you have businesses set up, right? So people are using AWS. They would like to, have that speed because you obviously don't have anything nearer to like in Denver or you don't have anything nearer to Los Angeles. So these edge locations will help, like have that near access. Okay. All right. So that's about your AWS. Now let's look at different services. Again, like I said, there are so many services that AWS has, but I'm gonna be discussing about the most important core services. But this is a cheat sheet that I'm sharing right now. Has a quick, like a quick 2 liners about each service, what it does. Although I do not cover every service in Amazon, but then the ones that you keep hearing here and there, those services, quick liners are available. I'm going to go through the most important services here and just give you a background of what that service does. Okay. All right. Let's start with VPC. So VPC stands for Virtual Private Cloud. This particular service allows you to create your own, virtual data center, if you may say, in the cloud, right? Like you can define your own network boundary, your own subnets, your own routing capabilities, your own public-private domains. So you basically are creating your own data center in cloud. Okay, that is allowed through VPC. So here is actually where we get into a lot of the networking concepts that we discussed. Okay, direct connect. So direct connect service allows a particular organization to have a direct connectivity to Amazon data center. So let's say you have a data center in your own company data center in Mumbai. Okay. Um, Now you are in the process of transitioning all your applications and your data from on-prem to cloud. Now, during the transition, right, obviously it's not going to be just overnight. You just won't do it in a single day, right? It will be few months, if not an year project to completely transition. So during that period, you may have certain applications that are already in cloud, certain that are on premise, or you want to push like some petabytes of data from your on premise data center to cloud. So for all those reasons, you need to have some good bandwidth, good dedicated bandwidth between a data center and the Amazon availability zones, right? So if you don't have this direct connect service, then you are using public internet. And we know that public internet can be flaky, right? Sometimes, you'll have disconnects and, it's not the consistent dedicated line, right? So with direct connect, you can set up that dedicated line. So when you go for direct connect service, Amazon will come set up, all the hardware required, and they'll set up the direct link between your data center and their data center, so that, you know, it's just going to be like an extension of your data center now. You're not connecting over public internet. You have a dedicated line. That's what direct connect service does. Route 53. Route 53 is the DNS service from Amazon. So, creating the DNS entries, or basically everything of related to DNS is handled through Route 53 service. Okay. EC2. EC2 stands for Elastic Cloud Compute. So this is the service where we create instances or virtual servers. Right? Depending upon your requirement, you can create a small server, a big server. There's different specifications: how many CPU, how much memory, how much network speed is allowed. So there are certain criteria from which you can select highly optimized CPUs, highly optimized memory. Right? Depending upon the application requirement, you can pick a particular instance type. So all of that, so basically creating servers is what EC2 service does. Beanstalk. So Beanstalk is a container service from Amazon, like your Docker and Kubernetes, right? Amazon has its own container service called Elastic Beanstalk. Lambda. Lambda is a serverless application. Okay, the easiest way to explain this is, for example, if you want to um, build an application that converts, or that compresses your video files, from GBs to MB, right? It's a video compressor application. Now, if you want to do that, right, you basically have to, run some servers, and on the servers you have to run that application which you're developing, which you're coding, right? And then you basically host a web server, which will also be the interface for the user. They'll upload the file, it will go to the application server, it'll get compressed, and then you give them a download link. So, but you have to maintain the backend infrastructure for web servers, for application servers. But as a developer, let's say you are the developer who is developing that tool, you don't want to manage web servers and application servers, and okay, will my server be able to manage these many users? How much storage do I need? You don't want to worry about all that, right, as a developer. You just want to simply write the code and give the tool. Lambda can do that for you. In Lambda, you can simply write your code and upload it to Lambda, and that's it. You can now basically host the same website out of Lambda without needing to worry about the backend infrastructure. Okay, so Lambda is really helpful for developers. They can simply focus on writing their code and uploading their code to Lambda. Obviously, Lambda behind the scenes is running it on some hardware, right? But we don't see it. We don't worry about it. It will take care of it. Okay, so it's a serverless application service. That's Lambda. EC2 container service. This EC2 container service will allow your containers like Docker to be run on the EC2. Okay, in AWS, if you want to run Dockers in AWS, you can go with this service. Then SNS. SNS is your notification service. For example, you want to be notified if a particular instance or server is down. You want to get an email, you want to get an SMS, or you want to get a push notification through some application in your mobile. SNS is a service. Cognito. If you want to integrate, some login mechanism for some AWS service, with I identity providers like Facebook or Gmail, so they can use their Gmail account or Facebook account to log into your service, right? Instead of you creating, your own local accounts, you want to leverage those identity providers, right? You can use Cognito service. IAM. IAM stands for Identity and Access Management. So this is where you would create user accounts. Let's say there are 100 people in your company who manages AWS. So everyone needs a login, right? All of that you do through IAM. So IAM is where you provide the user creation and management, what access you want to give. You want to give them full access, read-only access. All of that is IAM. Then you have S3. S3 is your simple storage service. That's the abbreviation of S3. So this is where you actually create, like this very similar to your Google Drive or Dropbox or OneDrive. Okay. But the key differentiator being, there are a lot of enterprise features like replication, like tiering policies, permission management, um, and others. There are auditing. There's so many other enterprise features that S3 provides, which you don't see in a Google Drive. Okay, so that's why S3 is really famous for those other enterprise, because the other services are already provided by Google Drive and such, but S3, that's where it differentiates. EFS, Elastic File System. So this is very much like the NFS share that we create in on-prem, right? We create an NFS share and multiple servers can mount that NFS share. Same thing with EFS. You can create an NFS share and multiple EC2 servers can mount that NFS. Snowball. So let's say I have some like maybe 500 terabyte of data in my on-prem that I want to move to cloud. So obviously, if I'm using the direct connect, that's probably okay, but still, right? How much data can it transfer in a day over the wire? Limited, right? Now, if I want to transfer 500 terabyte of data, it could take months to transfer. So there's a service called Snowball where you need to order for these Snowball devices, and Amazon will ship them. They're like suitcases. Um, I will show you how they look. So these devices will have hard disks included in them. Amazon ships those Snowball devices to your data center. So now you can do a local copy. That 500 terabyte, you can do a local copy from your devices to the Snowball devices. And once you're done copying, Amazon will pick them up, move it to their data center, and then they will copy it from those Snowball devices to the actual service where it needs to go to. And that's it. Now your data is transferred. In fact, Amazon also has a truck, a Snowball truck, which I think it can store up to, I think 40 petabyte. I think it's 40 petabyte of storage. They actually will drive that truck to your data center, and you have to connect your data to that truck and transfer. Once it transfer, the truck will then drive to the Amazon vicinity, and then they will transfer the data over. So yeah, they have those capabilities. CloudFront, this is the one that I was talking about that leverages the edge locations, right? If you enable CloudFront for a particular service. Glacier is very similar to S3, but Glacier is used for long-term data archivals. Like your tape, you use tape backups, right? Or virtual tape backups. You do the backups every day. You dump them to some tape or virtual tape. Similarly, you can dump your data backups directly to Glacier service. Instead of dumping it to a tape, you can dump it to the Glacier service. It's a cheap storage solution, okay, that can keep your long archival data for years and years. Storage gateway. If you want to use the storage from Amazon in your on-prem, either for backups or for creating snapshots of your local data in cloud, storage gateway needs to be set up. So it will act as a gateway for your storage devices. Uh, CloudWatch. CloudWatch is the monitoring slash alerting service in Amazon. It is responsible for, like monitoring your EC2 servers, your S3. It will basically monitor different services, your database services, to, maybe show you some graphs about the CPU utilization, memory utilization, or maybe alert you if the utilization goes beyond a certain percentage. It can do all of that. CloudFormation is the template tool. So, for example, if you in Amazon, right, like you have different services that you work with. So, let's say you're building up some application that for which you have to set up different services. You want to set up one EC2 instance, you want to set up one S3 bucket, you want to set up an IAM user. So, you want to do like multiple tasks across different services. Now, instead of manually doing that every time, and let's say those are repetitive tasks that you keep on doing, so instead of doing that every time, you can do that in cloud formation. You can set up a template that outlines these different tasks that you do, and you can reuse that template basically. Every time you want to do the same task, you can reuse that template. That's cloud formation. Cloud Trail is the auditing service. So if you want to log, okay, which user is logged into my console at what time, what are the actions they did, you want to monitor all those right? Audit logs. CloudTrail is the one that you can use. SQS is a queuing service. It's responsible for, like there's certain applications that need to have a buffer or a queue. So this SQS service you can use to create that queue. We'll discuss about that later. What else? RTS is the database service. So if you want to create like a Oracle database or a MySQL, MS SQL database in cloud, you can do that through RDS. DynamoDB is the NoSQL database from Amazon. Like, I mean, if you have heard about MongoDB, Cassandra, Hadoop, right? Um, so DynamoDB falls under the same category of those, but this is from Amazon. So this is the NoSQL database, DynamoDB. Redshift is the data warehousing database from AWS. So if you're running some, artificial intelligence or machine learning uh, kind of a workloads where you are running a, like, some 10,000 or some 100,000 transactions per second, right? You go for Redshift data warehousing database. Yeah. So these are some of the core services. Again, all of this could be Greek and Latin for you at the moment, but yeah, so when we will be covering each service, you will understand how to use and the value, and then you'll get familiar.
So are we going to discuss all
As
of
you
these?
know that
Not all of these, some of these, yeah.
uh, as you earlier said that why we are moving to cloud and what is the SaaS PaaS IaaS model? Are we covering
Hmm.
that?
Do you want me to cover that?
So public cloud, SaaS model, PaaS model, IaaS model,
Hmm.
hybrid. That
Okay,
is
right.
not covered, I think. Right.
Yeah, I mean, I can cover that. So this particular one, right? So your IaaS means infrastructure as a service, and the name itself reflects that all the infrastructure, like your networking, storage, server, these are provided by the cloud, and the rest of the other stacks is something that we manage, right? An example for infrastructure as services, EC2 service, where they are giving the server instance to us, and then we manage the rest of it. Platform as a service, along with your infrastructure, they also give you the, the middleware runtime, or, database also falls into this category. So they will give you the database also. The only thing that you have to manage is your application and the data that you put in, right? So that is something that we are owned by. So an example for this is the database service that is provided by Amazon called RDS, where they will give the database and we just have to connect and just start doing the transactions and queries. Software as a service, everything is managed by Amazon, right? There's no stake in us. We don't have any controls. All we do is we just use that service. Okay. An example could be like S3, right? S3 is a fully managed SaaS service where you only are leveraging that storage repository, because all we do is we copy files, we download files. We don't manage the backend infrastructure of anything, right? So every service that we have will fall into one of this model. Okay. Are there any other questions? Okay, guys, I think we are done for today then.
All right. Yeah.
Okay, alrighty. So we will meet again next week. So let me ask you this. If we have to maybe meet, like on a weekday, right? Uh, Around the same time, will that work for you, Beneath? And like if you have to, maybe if some weekend, not available or anything, and instead we want
Yes.
to do that on a weekday, same time.
Yeah, except Thursday it will work. Yeah.
Okay. Okay. Again, I let you know in advance, and we'll plan, make sure you both are available. Just wanted to put it out there.
Okay. Okay. Yeah, sure.
Okay. Ganesh, works for you?
Yeah, he just chat. He just.
Yes.
Okay. Awesome. All right, guys.
Yeah.
Then, yeah, have a
Weekdays fine.
great rest of the Perfect, Ganesh. Okay. Well, then have a good rest of the day.
Thank you.
Alrighty.
Bye, Mai.
See you guys. Bye.
Bye. Bye.